It is now given to me that the curve is actually tangent to the x-axis, which means that at a place where it is tangential to the x-axis, two characteristics must happen. Number one is the tangent, or the gradient of the tangent, must be equal to 0, because the tangent is going to be parallel to the x-axis. dy dx is equal to 0 at this point. And other than dy dx is equal to 0 at this particular point, it is also a point where it is touching the x-axis, which means that at this point, the y-coordinate is going to be equal to 0. So applying these two pieces of information, I'm going to try to solve for the value of k. First of all, I'm going to make use of the fact that dy dx is equal to 0. So by letting dy dx be equal to 0, we have 3x squared plus 6x minus 9 is equal to 0. Which means that x squared plus 2x minus 3 is equal to 0. Factorizing this, x plus 3 and x minus 1 is equal to 0. X is equal to minus 3, or x is equal to 1. Which means that I know there are two possible points when the curve is tangent to the x-axis. One of the point is when x is equal to minus 3. And when x is equal to minus 3, y, according to what we discussed, is equal to 0. So if I were to sub these two pieces of information back into the original equation, what we have is minus 3 to the power of 3 plus 3 minus 3 squared minus 9 times minus 3 plus k is equal to 0. And this will actually allow us to solve for one possible value of k, and that is minus 27. I'm going to repeat the process again when x is equal to 1. And when x is equal to 1, y is equal to 0. Substituting these two pieces of information back to the original curve, it is going to be equal to 1 cubed plus 3 times 1 squared minus 9 times 1 plus k is equal to 0. And this alternative value of k is going to be equal to 5.